The purpose behind this letter was to teach my grandmother how to solve a pre-calc problem. I will read you this letter and the steps that it says to follow. Dear Grandma Iva, I have been assigned a great task to teach you one math problem. In this letter, I will do my best to teach you how to solve h of x equals 1/2 x to the third power plus 3/2 x squared minus 5x. First, you want to make sure it is in standard form. This means each term is in order, which in our case it is, and you can tell by the exponent. Now you move on to identifying the lead term, slope, degree, and end behavior. The lead term is the first term of the equation when it is in order. It also determines if it is up or down, positive or negative. The lead term is positive 1/2 x to the third power. Our slope is the change in y over the change in x. You may also know it as rise over run. The slope determines how fast, slow, skinny, and wide the fraction is. A whole number makes the graph of the equation fast and skinny. In our case, it is opposite with a fraction. So, our slope is a fraction, and it makes it slow and wide, going half the speed, with the slope, or m, or a, equals 1/2, rise over run. The degree is what tells you how many possible outcomes you have. You can find the degree in your lead term. The exponent in the lead term is our maximum amount of solutions. If the degree is odd, you can have a minimum of one solution, but when even, you can have 0. Our degree in this equation is 3, as shown there. End behavior can be a little tricky to understand. I will give you the basic knowledge. End behavior tells you how the graph starts and how it ends. There are 4 different ways. 1. Start on the left side negative and go to the right positive. Start on the left side negative and go to the right negative. Start on the left side positive and go to the right negative. Start on the left positive and go to the right positive. In our case, we are negative positive. When reading end behavior, you say as the fraction h of x is the function h of x is approaching positive/negative infinity. And end behavior has 2 parts, as it approaches the negative side and as it approaches the positive side. Our end behavior is written like this. As f of x is approaching negative infinity, x is approaching negative infinity. As f of x is approaching positive infinity, x is approaching positive infinity. Next is our y-intercept. This is the only point that touches the y-axis, which is the axis going up and down. In standard form, the y-intercept is the d, as shown there, located at the end of the equation. Since we do not have a d term in our equation, the y-intercept d equals 0. So our y-intercept point is as follows. 0, 0, the origin. Our next step is to set the equation equal to 0. This is fairly easy. You just exchange the h of x for a 0, as shown right there. After you do that, you want to reduce by factoring out a 1/2 x from all terms, shown there. Now go back and check your work by distributing or multiplying then the 1/2 x to each term and getting the original equation. So 1/2 x times x squared equals 1/2 x cubed. 1/2 x times 3x equals 3/2 x squared, and 1/2 x times negative 10 equals negative 5. It all checks out. The next step is to solve the equation. To solving this equation is factoring out the group above, like so. Again, make sure to go back and be sure it checks out. In our case, it does. From here, you can go to solving for x. Each one of the sections of our equation is a solution. You have to set each to 0 and solve, as I've done. So now we write those as a solution set, which means we group them in order as a list of all possible answers, like show. From that step, we would plot the points on a graph, then make a t-chart, like I did. You won't be able to draw the line until you have an idea of where it goes. A t-chart does that for us and gives us a better and more accurate graph. You want to choose points from every interval. And there are the intervals. You want to choose and then insert that number into the original equation and solve. Here's my t-chart. You may choose to do 2, even 3 from each interval. The more you have, the more accurate the graph becomes. After that step, the final is to graph and label. You would plot all of your t-chart points, but when you draw the line, you would not stop at that point and go to the next. You wouldn't, because you do not know the minimums and maximums of each interval. So now let's graph. Now we are done. Good job, Grandma. Lots of love. Me. And the end.